So far yesterday we have covered like they are like I told you they are building blocks, like it means they are very very fundamentals, like so many we have seen like up to DWH, like why? Because they are the blocks on that we are going to build our platform, like so they are fundamentals, they are very important to understand. That is the final point. So today the next topic is like data modeling. Today we will, what are the things we are going to read is data modeling. In that there are some types, ER model and dimensional model. As of now in the present scenario we use dimensional modeling more and more. Straight away they may ask questions like questions come from dimensional modeling only. What is dimension model, and what are the things generally happen when compared with ER model? Such questions directly in interview questions there are good chances to come. And one more thing is modeling is something like architecture work. It is, you may think like modeling generally, to model a block or to model a system or a software, like modeling is a developer work generally it looks like. But why as a tester in ETL testing we should know modeling? That is also important. That you will understand here in this class. And to build a dimension model, what are the things we need to achieve? And in the dimensional model there are the two fundamental factors are facts and dimensions. And what is fact and what is a dimension, that we will read here. And types of facts we will read here. Types of schema, as I mentioned already, schema I have mentioned in the beginning. So here we will read the types of schema in dimensional model, not general schema. It is, as I mentioned, schema. That's why when the similar word comes, you have to understand the difference between them exactly. Schema, as I mentioned, see the concept is same again behind schema in DM, I mean dimensional model schema. Here two things will come like that. As I mentioned earlier, the schema is a particular structure that we have designed in a particular database. Let us say same example I will take. There are different branches in a bank, B1, B2, B3. So generally B1 branch will follow a particular structure of tables to collect the data, or a particular structure of a table to collect the data. And in the same way B2 also, B3 also, it means they may have different schema. And this, when the schemas are different but data is same, homogeneous only, as I told you already, this all branches again will connect it to the head branch, right? So when the head branch is connecting to all the different individual branches, it should be adaptable to B1, it should be adaptable to B2, and it should be adaptable to B3 also. Then only you can collect the data simultaneously, or that we can say like normalization. If any differences are there, if any redundant data is there, that we will remove in ODS and we will store in the ODS. From ODS, you know that actually ODS 2 we will do transformation and then we will load to the DWH. This is what schema in generally we have studied so far. But here the dimensional modeling schemas are different, that we will see. And there are three types of schemas like star, snowflake, and galaxy schema. And then types of dimension, what is dimension, and types of dimensions. This we will read in this class. So firstly, data modeling, and why testers should know this. I told you data is the term which is common everywhere, like we use from beginning to ending, like because we work on the data. So data modeling. See, for suppose generally we have data in a particular industry or in a particular store or in a particular big factory. So we know what are the parameters we need to collect the data, because that business people will give us. See, as we are modelers or testers, the business people will come to us and they will give us test data. It means these are the parameters we have, like. So by seeing that data, we have to model. It means we should have a particular structure to handle the data. It means structuring a data in DWH is called modeling. Generally we do all this work in DWH only, and we structure we structure the DWH in a way it handles or it takes different data as an input, different data is input, and we get some output data after transformation or after changing. Maybe at analysis also, even for the analysis also in the DWH, we have all the data. But for analysis, the particular queries the business people will ask, to that particular queries, we have to answer. It means that structure we have to design in the beginning. So the designing a particular structure to handle the data in DWH is called data modeling. So this is what data modeling. So next, why testers should know this? Actually, as a developer, you can understand, you should know that actually data modeling. It means how exactly it is, how the sequence it is following like. But as a tester, generally you don't need to know. You don't need to understand modeling, fully. But in order to understand the completeness of the design, it means where the data comes, how the data is, what type of data is there, and how many sources are there. After that, where it is going first, and what are the transformations are occurring. Is there any ODS is there in between? It means any, what are the staging areas? I told you already, staging area means where you can do some conclusions like. So what are the staging areas and how many staging areas are there? Where at what points the analysis are doing, they are doing. Not only in DWH, I told you, DWH is for completely analysis like OLAP, but at different stages also we do some analysis based on the data we have received. So in order to know the completeness in the design and understanding about validation, like, validation means at that point, if any errors are there, that you can correct. So in order to do validation at a particular scale or at a particular point, and in order to understand the completeness of the design, the tester also should know the data modeling. So why means, I told you, to know completeness and validation. Completeness in the design and validation. These are the two purposes the tester should know data modeling. So data modeling techniques are two. The classification is like ER modeling. What is the data modeling? So the first one is ER means entity relationship modeling. Entity relationship. The second one is dimensional modeling. See, the name itself, I told you already in the beginning, also from the beginning onwards, name itself all time reveals something that you need to understand first. Entity means a particular, we have seen in the beginning also. Entity means it's like a table. So when they are related different tables, that is called entity relationship. Generally, it is old and traditional one, and so generally it suits for big corporates like old one and traditional it is. But generally, we in the present scenario, we are not using this one. We mostly concentrate on dimensional modeling only. But we should understand what are the differences like that. So here, table to table, entity to entity, we relate in this modeling, and suited for, I told you, corporates. It means big industries. In the starting, we used to do in the corporate industries, like mostly, here redundancy can be removed easily. In the ER modeling, redundancy can be removed easily. Redundancy means a data which is repeating like. So repetitive data can be removed in ER modeling like. So that is what actually entity relationship modeling, and I tell you the differences also after that. Just first we let us see the definition of it. Coming to dimensional modeling, it is advanced. I told you it is suitable for the present scenario. Why means actually why? Because here basically our fundamental point is like, here query, against that queries we have to do analysis. So this is the fundamental, right? From the beginning onwards, we are turning around these two things only. When the query comes, I have to do answer. I should answer them. It means I have to give analysis for that queries. So that is easy in the case of dimensional modeling. That's why I told you it is advanced and suitable for the present scenario. And mostly business analysis measures we use this one. It means business analysis measures can be done here in dimensional modeling and optimized for online queries and DWH tools. It means whenever the DWH tools are connected with this modeling, it is optimized. It means, like I told you, one special characteristic, key characteristic in DWH, ad hoc, queries it accepts like. It means the questions are ad hoc. It means a particular time will come and go like. So that adaptability is there in case of dimensional modeling. That's why it is optimized for online queries and DWH tools. So in this, we have facts and dimensions. After that, we will see this one. It is mainly comprising of facts and dimensions. And dimension is one more word that you can understand, like, one dimensional. It means only x-axis, like two dimensional. It means y-axis also will come. When three dimension comes, like it is cube, like, right? Cube. When third variable is there, x, y, z. When third dimension comes, it is like a cube. That's why it is a cube is the fundamental block in dimensional modeling. So now we will see straight away what are the differences between them. ERDM, entity relationship model and dimensional model. Here generally data stored in RDBMS. You know that we already have seen this one. RDBMS. It means relational database management system. Why? Why relational? Because there is a relation between one table to another table in that particular DBMS. That's why we call it as RDBMS. So data stored in RDBMS in case of ER modeling, here stored in multi dimensions. Here data is stored in multi dimensions. I told you multi-dimension means the variable. The spatial, it is like variable x, y, z like. It means it may be 3 variables, 4 variables, 5 variables, any number of variables can be taken. When it is dimensional model, when it is cube model, remember it accepts mathematical analysis. But in the case of RDBMS, it accepts logical, it may accept logical relationship, but mathematical relationship is not possible. Let us say, I give you as an example. Let us say a big system is there. Let us say table 1 linked with table 2, table 1 linked with table 3, table 3 linked with table 4, table 4 again linked with table 1, table 3 linked with table 2. Like, see, this is like RDBMS, relational database management system. See, definitely by seeing it, you can understand it is complex. In order to get answered my queries or business queries, very difficult. I have to do more and more analysis in the case of ER model or RDBMS. Coming to multi-dimensions, you see the advantage. Let me take T1 as a variable. I take in one axis. T2 is another variable. It means table 2 values, like that entity values I am taking in another dimension. Table 3 I am taking another dimension. Table 4 I will take another dimension. Or maybe in table 2 itself I will add it. Or in table 1 I can add it. It means, see, now all are linked to a particular point. It means I can get any value. Like an image, if you remember, if you have little idea about 3D image, see, let us say there is an x, y variable, 0, 0, 0, 1, like values will be there. At every x, y value, you have third dimension value, z value. Let us say it means 0, 0, 0. This is the first point. It means their intensity value is 0. 0, let us say 0, 1, 2, 1, 2, This is what 1 comma 1. 1 comma 1 comma at that particular point z value may be 10. Let us say this is 2 comma 2 comma 20. It means at that particular point the value is 20. It means the third dimension value you can easily identify by taking first dimension and second dimension. It is like more like statistical method, mathematical method. So generally whenever you see dimensional modeling, it is a mathematical analysis related. That's why we can understand or we can do analysis easily against queries from the business people. So that's why we go for, I told you, we mostly do dimensional modeling only. So this is first thing, one difference I told you, RDBMS, and it is multi-dimensions that the data generally we store. So examples are this. That is the first point. The second difference is, tell me.
AMMAJI.
Yeah.
Data storage will be same in both the places, or how it will be? So that
Where in ER model or your DM model?
the DM model.
In DM model, see table 1, table 2, they are different databases.
Different databases. Okay.
Different databases. It means maybe like you can say like different tables. So each table to table, definitely there is some relation like by using foreign keys, you know that actually primary key, foreign key like.
That is in RDB. But here I'm asking.
In dimensional
DM
model.
You no need to relate all these things directly. How we can extract and how it will work inside, that's what my question.
When you know, I mean, that's right. Next, facts and dimensions will come in the dimensional modeling. There you can understand easily. You know how exactly the fact and dimensions we have, because you know the values are stored in the two quantities only, fact and dimensions only. So here finally, you know, I mean, easy thing is like T1 is one table, T2 is one table, T3 is one table. They are like temporary, you know, tables like that. Tables are linked. In ER model also the tables are linked. In DM model also the tables are linked. But how the way we are linking, that is important. Here in DM model, mathematically we can access all the tables easily. But in RDBMS, we have some logic. But whenever the query comes, I cannot give answer immediately. So the examples I will show you. Whenever I show the block diagram, it will be easy. As of now, you try to you should get one point like we use an RDBMS to store the data in ER model. In dimensional model, we use multi-dimensional technique. Okay. So multi-dimensional techniques, for that understanding, I have taken that image as an example. In image, third dimension generally no one can see because the x comma y, that is the face you can see. But behind the face, there are 3, 4, 5 values will be there in an image. They are color values, you know that, like RGB values, like something. It means behind also there is a column of values, nothing but it's like a table.
Okay. Yes, AMMAJI can.
Yeah. So next difference is tables are units of storage. In ER model, here first thing is RDBMS we store data in RDBMS. We store here in multi dimensions, like there is the first thing. Example like an image I have taken. And the second thing is like tables are units of storage. It means here unit means, you know that is the fundamental part. In ER model is table only is the fundamental part. Between the tables we have some relation, we make it. But here cubes are the fundamental. It means cubes are the units of storage. It means what is the minimum storage in DM model means cube. This is important question, and maybe in interviews they may ask. In ER model it's a table only, but in DM model it is a cube. Cube means, again you see, it means tabular data. What is the tabular data available in ER model? The same, but here the unit is cube. Why cube means, again I told you, to retrieve the data easily or to do some operations or analysis. This is easy technique or mathematically easy because it is mathematically related. So cubes are unit storage in DM model. Here tables are units of storage. So volatile and time variant, this you know that volatile means it's ever changing, like, and time variant means in a particular time it will vary. But it is non-volatile, but time variant. If you see, this is almost looking like DWH. In DWH also characteristics, if you see, like, it is, that is non-volatile and time variant. The same thing like here also. Here SQL we can use for manipulation. SQL is used for manipulating data. Manipulation means manipulating of data. But here ETL tools can be used. That's why ETL is adaptable to this dimensional modeling, as earlier I said. ETL is used for manipulation here in this case. So now out of these characteristics, out of these differences, the final thing is like, here only you can get manual normal reports. It means I told you, because in ER model, when the queries comes, like, you cannot generate user friendly or something like mathematical reports instantly. But in the case of DM model, you can generate user friendly reports and interactive. It means easy to understand. They are very easy to understand. That is what we call interactive reports can be generated, and user friendly reports can be generated in DM model. But in the case of normal ER model, you cannot generate interactive reports. Again, from the beginning, if you see, out of given data, finally what actually in the analysis part, where we are generating reports and dashboards, that is important from end to end, like. So who are all can do that task easily. It means from the given raw data to reports, who are all can do easily, that we choose. So here out of this, by seeing the differences between ER and DM model, so this DM modeling only I prefer. Not only me, everyone, generally we prefer DM model only. Because finally my outcomes are my reports are user friendly and interactive and less time consumption, like. So this is the difference now. So now how to build. So in order to, let us say, one simple case we take, one industry businessman came to me and he is asking to design or to build a dimensional model to do to have some analysis. So firstly, what generally I need to understand. So first I will sit with that business people, very basic people, where the, like POS people who are all making that transactions and all. With them I have to sit. Then they will tell all the requirements. Sir, this is our business. This many people will come. These many products we have. These many departments we have in the industry. All the data. It means first thing, in order to modeling, I mean to build DM dimensional model, first I have to collect all the requirements. It means you have to gather all the requirements from that person or from that industry, and you should have some abstract out of it. Abstract means that from beginning to end it is like, it means it is the whole thing. You should have a view of abstract. That means conceptual model. It means at this moment you have a concept in your mind. With that concept, you will model something in your mind or on a paper. That is called abstract. The conceptual model you should have in the second requirement. Then next thing, see, you may have concept, but you should have logic, right, to run that concept. So you have to design a logical model in the third point case. Logical model design, that you have to do at this stage. It means business requirements generally they described in case of attributes only. It means we have seen columns or fields, because in the requirements itself we have written so many attributes. What are the attributes, what are the products, what are the departments, how many people are there, how many staff is working, everything, like. Whatever the attributes I decide here only. In the abstract, I have theoretical model. Coming to logical model, I see all the attributes are covered or not. It means all the columns are there or not. All the entities are there or not. So logical model I will design. And then finally, I design physical model. It means physical running model I design. So whatever the data you work, these four things are very, very common. Like even in DWH also, we have seen this. Any system to work upon it, we have to see these four parameters. Now, in dimensional modeling, I told you the building blocks for fundamentals for dimensional modeling is facts and dimensions. Where morally here it will come like your answer, like facts and dimensions. So before that, in order to understand these facts and dimensions, I hope you are clear with this primary key and foreign key, right?
Yeah, AMMAJI. Yeah.
Primary key, fundamental, like primary key means the name itself it is there, like which is fundamental. Foreign key is like something like you adopted. It is generally foreign key is a primary key, another table. Like let me give an example, because actually these things will concept is useful in facts and dimensions. Let us say there is a table having different attributes. Let us say 1, 2, 3, 4. 1 is the primary key, let us say. So now that 1 I use as a foreign key, and here 5, 6. Different data is stored in another table. So here 1 is a foreign key where I can access 5, 6 values also. It means fifth field and sixth field. Let us say I want fifth field with respect to 1, or I want a fifth field value with respect to 3 or with respect to 4. It means generally these tables are linked. Why? Because this is foreign key is the primary key in the first table. This primary key is the foreign table in the second table. So generally foreign key allows us to relate two tables. So that is basic, for keys. Like this time is up. What I should do? So I do one thing. I close and I share once again. Vijay, is it okay? Hello.
Yes, sir.
Yeah. I
Yes,
will
sir.
close this session and I will share one more link. Okay. Thank you.
Okay.
So okay, I repeat the little line. So in this dimensional modeling, facts and dimensions are the fundamental parts. Facts having dimensions with numeric values. Dimension is the descriptive value or quantity, or sorry, descriptive or entry point. Nothing but you can say like fact is a quantitative parameter. Quantitative. It means measurable parameter. Dimension is a qualitative parameter. Hope you understand. Now I will show you one table so that you can easily understand the difference between them. See now, this is one schema. Schema anyhow, not command. Now after that, I will explain you what are the facts and schemas. But this is one type of schema that is called star. See here, sales fact table is one table. This is fact. It means this is fact table. See in this, foreign keys are there. FK means foreign key. See item underscore key, time underscore ID, branch underscore ID, location underscore ID. These are the four values. It means see, for analysis, you should have some numeric values so that it will be easy, not descriptive. But dimensions have descriptive parameters too. Here, primary key is there, item dimension table it is. What it is, item underscore key, item underscore name, brand name, sold by category. In the same way, branch, location, time. These are dimensional tables. Why? I already told you dimensions have a descriptive values. No need to have only descriptive, but generally it is more of descriptive. But coming to fact, when you coming to fact, it is only numeric. Most of the cases it is numeric. That's why see, quantity underscore sold, the value easily you can obtain out of fact table. Amount underscore sold, that value also you can easily understand out of fact table. Average underscore sales, this is also easily you can obtain by using fact table only. It means out of fact table you will do analysis, or queries can be answered easily out of fact table, not out of dimensional table. Now I think that question you asked, Murli, I think it is clear.
Yeah, I got it now.
This is the thing, like, so dimensions have different tables. Now you see, when it is like let us say these are 4 dimensions, like behind this fact table, these 4 dimensions will come. You see in RDBMS, something like there is no structure, or there is no schema in that. You have some logic you have definitely between the tables, but this fact is not there in that, because fact is a centralized thing where you can access any dimension easily. So that's why it is a centralized concept. So fact is a centralized one in the schema. So this is one type of schema, but schemas I will explain now. So hope it is clear.
No. Yeah, Ammaji, got it.
So this is what actually facts and dimensions. So generally there are different types of facts are there. Types of facts. Then we will go for schemas. There you can see this star and all. So types of facts are additive. Just now that example we have seen, it means aggregation are easily can be obtained out of dimension. It means average value or something like additive fact. Semi-additive. Why semi means, see, you no need to add all the tables data together. Maybe some tables you can add, or aggregation can be done in fact. That is what is called semi-additive. Non-additive also. And factless facts also will be there sometimes. What does it mean actually? When you say factless, there is no numeric value. It means there is no quantitative parameter. Only qualitative parameter only you can get here. This is different. These 3 are different. These 3 are generally they will give numeric values. These 3 will give numerics. It means all mathematical analysis, whatever the mathematical analysis that can be done, these are like under these 3 will come like. When you say factless, fact is numeric. Numeric less it means there is no value. It means there is no quantitative parameter in this. So that is what actually we call factless fact. In the same way, dimensions also will be there. We will see the dimensions after that. But now let us see types of schema. So schema, types of schema. In dimensional modeling. Remember, we are reading under DM only. We are not doing any, we are not reading anything under entity relationship modeling. We are doing only dimensional modeling. So here 3 types are there. Generally, if you see the books and different any websites and all, sometimes they stop with one schema. A few people stop with 2 schemas. Few people stop with 3 schemas. That's why types. As I said earlier, there are many words they are using for one for another. Like that's why types also. Few people are saying like 3 classification. Few people are giving like 4, 5, 6. Even you can see that facts also. Few people say that the 10 types of facts are there. You should understand the basic of that. After that, anything you can adopt it. So central crux you have to understand. That is the thing you please try to understand. So here 3 classifications I'm going to give. One is star schema. The name itself like star schema. Snowflake. Galaxy. Or constellation schema, they say sometimes. Constellation. See, just now we have seen that example like star schema. Star means, you know, the, what you call, the figure you can easily draw it in. Right? This is star. Now, why they put name star schema means generally fact is located at the center here. And dimensions they will do like this. Let us say dimension 1, dimension 2, dimension 3, like many dimensions. Any number of dimensions you can give based on the star and you are drawing. Okay. Now, out of a query, the data, maybe you need to do analysis. Where from you have to start? From the fact you have to start. It means because already fact is linked with every dimension. Few, at few cases, junk dimensions also will be there. There are types of dimensions that I will explain there. You know, what are the dimensions types like. But as of now, you understand the fact is centrally located, which is connected to all the dimensions, whatever the number you mentioned in this figure. And whenever the query comes, you can draw the analysis out of that. So that is what actually star schema is. Generally, it looks, why star schema is the fundamental means it is simple in structure. It is easy to understand and simple in structure, and query effectiveness is good. It means, you know, immediately you can answer or you can do analysis, and processing time also less. Processing time also less in the case of star schema. Coming to Snowflake schema, same again, you know, the fact table you already seen in that example I have shown. Dimension you have seen. Here Snowflake schema also a star schema. Also, it means it is also a star schema only. Then what is the difference then? But here along with the star, you have many lookup tables. What is LUTs? LUT is also like tables only, tabular data only. It means in each dimension again, there are many tables that are again linked with fact only. It means what is the difference between these two then? Processing time definitely will be little more in the case of Snowflake, but effectiveness will be high. More data you can handle easily when you mention LUTs like. So that is what actually Snowflake schema. Coming to Galaxy or constellation, it is the combination actually. There is no, you know, separate thing like I told you. Constellation means you might understand this, what you call the satellites, you know, some symbol will be there like this. Different satellites will rotate actually, you know, around us, that where, you know, how we are using internet and all this thing only. It is means constellation. It means a group of things like group of stars, you can say that. So it is more complex, more effective, but processing time will be high, but more effective. So this is what actually constellation means, a combination, you know, a group of a bunch of stars are available in this constellation schema or galaxy schema. The name itself it is showing like, you know, what is the galaxy means, you know, now grouping of stars is called galaxy like. So the same definition here also will happen, but the difference you have to understand effectiveness and time. As you go more and more effective, generally time consumption will be more unless the design is very clear. Maybe in that case also, when you handle with large data, with large number of stars and large number of tables and dimensions, if you have such a design and such a physical design, such a memory full design, maybe time will be less, but generally it is not possible. So that's why time consumption is growing more and more, as you know, one schema to another schema, but effectiveness will be also high. These are three types of schemas that are there in dimensional modeling. Now we will see the dimensions. We see the dimensions. So here also I told you there are many types generally they mention. The first thing is conformed dimension. Conformed dimension. The next one is junk dimension. The third one is degenerate dimension. Fourth one is role playing dimension. After that, there is some other concept will be there like SCDs, slowly changing dimensions. Slowly changing dimensions. This concept we will see. I think mostly tomorrow we can see this thing. But what conformed dimension is, this is again in that dimension modeling, what are the fact and the dimensions related relation we have seen in that only we use this thing. So conformed dimension is same when it is being referred from various facts. Okay, it means there are many facts in that. Let us say fact 1, fact 2, fact 3, D1, D2, D3, D4, D5. Remember, these are all are linked. I cannot give you exact logic like how it is linked like, but they are all linked. Now see, I want a particular dimension. See, suppose it is like, if we three see something, we see in different manner, right? Because we know that actually మనం ఒక వస్తువుని ఏదైనా చూసినప్పుడు రకరకాలుగా చూస్తాం. But if you see from any fact, this should not change. Let us say the D1 is not changing. Let us say the D1 is not changing by referring from F1, by referring from F2, by referring from F3. It means if you see from F1, D1 is D1 only. Let us say D1 have some quantities, 5 quantities. So 5 quantities only it is having. If you see from F3 point of view, F2 point of view, if all are same, if D1 is same out of all point of views, then it is called conformed dimension. Junk dimension. A dimension consisting of only flags, like here generally some parameters we can say that whether it is yes or no values only we do in the table. Okay, it means suppose the product is good, you can represent with yes. The product is bad, you can represent with no. It means it consists of flags. That is called junk dimension. Flags means by seeing that you can understand whether it is color or what color it is, whether it is good or bad it is, like that you can understand. So that is what we call junk dimension, the dimension having only flags. Degenerate dimension. This is a key is not related to any dimension but use it to but link to a source. Like source means again, I think now this guy, 1 second, I think someone is entered. Yeah, okay. So what is the next one? Degenerate dimension. A key, this is which is not related to any dimension. Let us say here in this dimensions we use primary keys and foreign keys also. First, suppose there is a key which is not related to any dimension. It means it is not related to D1, it is not related to D2, it is not related to D3. Which one? A key means it may be a primary key or foreign key to any dimension but linked to a source. Source means again a centralized fact. A key is related to centralized fact but not related to any dimension. That is called degenerate dimension. The name itself it is there. Degeneration means it is not linked with the dimensions but it is linked with the fact. Role playing dimension. one dimension related to more foreign keys from fact table. It means from the fact table, if the dimension is related to more foreign keys, then it is called role playing dimension. After that, slowly changing dimension will come. We will see this part in the next class. So far, if you have any doubts, you can ask me. So today, as I said, data modeling is done in the types. I think someone is speaking. Building a model, facts, dimensions, types of facts, types of dimensions, and schemas what we are using in modeling. These are the things we have.
Sir,
Yeah, tell me.
sir,
Some
snowfall model explain with diagram, sir. Snowfall model.
I'm not getting.
No, snowfall.
Disturbances.
Snowfall schema. Snow explain with diagram, sir.
Yeah, okay then. If you want, that same like star schema.
Yeah.
Already I have shown you diagram, right? See, this is right. So Snowflake, what I
Snowfall.
said. Yeah, Snowflake schema, in that each dimension it will have some LUTs. It means lookup tables. It will have. It means under the dimension, under each dimension, there are another dimensions will be there. It means each dimension will have two more dimensions. Like so, okay, that I can show you in the next class. I will show you the figure, and figuratively I will explain how it is going to look. Okay.
Okay.
Yeah. Any other? All
Sir.
right. Yeah.
Sales of table అని ఉంటుంది ఇక్కడ.
Yeah, sales table. Okay.
Quantity sold, AFT sold. ఇది ఎట్లా స్టోర్ అయింది మళ్ళీ ఒక టేబుల్.
Which one? Fact.
Quantity sold, AMT sold.
These are aggregations. These are aggregations. It means for analysis only we use. It means out of the data stored in this DWH or fact table, I told you when the query comes, like query may ask like anything, like right. He may come after 3 months and he may ask like average sales. That time these are the values. It means analysis values. These are, and this value, these are the values you can get, in analytical tools. Like it means BI tools. By using BI tools, you will get that value. This is like output. Okay, out of the closed box, these are the outputs. These are the dashboards. Like I can say like these are the dashboards. Dashboard values are quantity under sold, amount sold, average sales. Like these are reports. Okay.
Okay, sir.
Yeah.
Okay.
Thank you then. So see you in the next class. Then I will show you that other schemas also. Okay. Thank you. Can I wrap up?
Thank you.
So I will share that last video and today videos all together. I will share in the group.
Okay.
Thank you. Yeah.